Hello friends, I am Krishna Kanjani from LJ Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of machine. In this session, we will learn about gear. In today's session, we will learn law of gearing, and this law of gearing is nothing but a simple condition for constant velocity ratio of gear. Okay, now as we are aware that to transmit power from one shaft to another shaft we are using gear. Now the gear mechanism is very essential and very useful nowadays to transmit power in various systems. Now the main advantage of gear system is that it is transmitting exact velocity ratio, that is from input to the output shaft. Now to do so, there is certain condition that must be satisfied while designing that gear, and that condition is derived in this formula, that is law of gearing. Let's consider, let's start that how it is derived. So let's sketch or consider one gear, that is gear A, which is having gear tooth with respect to its center point O1. Now this gear A is meshing with another gear, which is gear B, which is rotating about its center O2. So we can say O1 and O2 are two centers of gear A and gear B. Now these gear are meshing at point. Okay, so let's consider this point as point Q, this contact point as point Q. Now this Q point can be termed on gear 1 as well as on gear 2, because while we are considering rotation of gear 1 with respect to angular velocity omega 1, that time we can consider point Q on gear 1, while if we are rotating due to this omega 1 rotation, gear 2 is rotating at angular velocity omega 2. So at that time we can consider point Q on O2. Okay, so point Q is a common contact point. Now with respect to this point Q, we can sketch two lines, common tangent and common normal. Let's consider first one, that is common tangent, which will be passing in such a manner that it is making a common tangent between them. Over here in this sketch you can refer like this line which is joining this TT point. Okay, now in a similar way we can sketch common normal which is perpendicular with this surface, and the same time this common normal point if we consider as line MN. Okay, now we can sketch as it is a common normal, it is perpendicular to this Q point. Okay, now in a similar way we can consider that if we sketch perpendicular from this O1 on this common, and it is giving certain point on this common normal, which is again termed as point M. Okay, so on this common normal line we are projecting two perpendicular lines which are making 90 degree at this common normal point. So here it is point M, and similar way we can sketch one perpendicular line to this common normal which is intersecting at point N. This angle will be 90 degree. Okay, so now with the help of this diagram, now we can consider this as a closed triangles. Okay, so if we consider, now if we join point Q with point O1, so this is your triangle 1, and similar way if you connect this O2 and Q, that will be your triangle number 2. Now as O1 and O2 are two centers of two gears, then if we join this O1 and O2, then this O1 and O2 line will give you point P, which is a common contact point. Okay, in this diagram you can refer even over here that initially what we have done, we have sketched center O1 and O2, and with respect to this O1 and O2, one profile at Q point and another profile at Q point. With respect to this Q point, we have sketched point M and point N, and a similar way point O2 and point O1. Now gear 1 is rotating with omega 1 and gear 2 is rotating with omega 2. Okay, now at this time we have just made one arrangement that we have two triangles, triangle O2PN and the similar way triangle O1PM. Okay, now while transmitting power, we are aware that the velocity which will be always perpendicular to this point. Okay, if you consider point Q over here, so if you want to find out linear velocity, then linear velocity of point Q with respect to this O1 line will be always perpendicular to this. Let's consider that is velocity V1 of point Q. On a similar way, we can sketch velocity of Q point with respect to gear 2, which is termed as velocity 2 and will be again perpendicular to this O2Q line, and it will be in an angle somewhere like this, which is your V2. So now we have two velocities, V1 that is linear velocity of gear 1 and V2 that is linear velocity of gear 2. Okay, now while transmitting power, we are aware that this linear velocity has component on this common normal, which is termed as a linear velocity V. If we consider this linear velocity of V, then we are aware that while meshing, this point Q has to travel in such a way that it has the common velocity V which is same. So for example, we can say that a component of V1 along this velocity line and component of V2 along this velocity line must be same. Then and then they will transmit power with the same velocity. Okay, so over here we have to identify the component of V1 with respect to V. Let's consider the component of V1 with respect to is making an angle alpha over here. Okay, so over here we can sketch like the angle between them is let's consider angle between them is alpha. V1 and V with respect to them angle is alpha, while V2 and V is making angle beta. This one is your angle alpha and this one is your angle beta. So over here we have to identify component of these two and it must be same. Okay, so let's derive the equation. So over here we have to identify that V1 cos alpha and V2 cos beta must be same, that the velocity component of V1 along this common normal line and component of V2 again along with this common normal line must be same. Okay, so we have equation V1 cos alpha is equal to V2 cos beta. Okay, now from this let's first identify the general equation that the linear velocity V is equal to radius into omega. V is equal to r omega. This is a basic equation that you have learned in your past physics subject. Okay, so over here we can say that for V1 we can say r1 omega 1 and for V2 it is r2 omega 2. Now for r1 here over r1 is equal to O1 into O1 to distance q, O1q is radius for gear 1 and O2q is radius for gear 2. So we can say that omega 1 V is equal to r omega. So over here omega 1 into O1q cos alpha is equal to omega 2 into O2q cos beta. Okay, now second term that is cos alpha and cos beta. Now derive the equation and terms for q1 and q2, cos alpha and cos beta. So over here for cos alpha we can say that for cos alpha component, here the alpha component is with V1. Okay, now the same angle, if you consider this line is perpendicular with this one, and similar way this line is, let's consider, and this second line is perpendicular to this one. So intermediate angle alpha will be same in both the cases. So over here alpha we can term over here, and similar way beta, because for this arrangement also this perpendicular line which is matching with this velocity V2. So over here the angle beta will be same in both the cases. So beta will be transferred to this position. Okay, so now we have to derive equation of cos alpha. So let's sketch this arrangement once again for only this triangle. Okay, so now for triangle this. Okay, so over here if you want to identify cos alpha component, so cos alpha is equal to adjacent side upon hypotenuse. Okay, so adjacent side, that is equal to O1m, and hypotenuse, that is equal to O1q. So O1m upon O1q, and a similar way adjacent side over here will be O2n upon hypotenuse, that is O2q. So we can say O1m upon O1q. Now this term can be cancelled out from both the sides. So we can derive that omega 1 into O1m is equal to omega 2 into O2n. Okay, so now from this equation we have to derive that the angular velocity ratio omega 1 upon omega 2. So it can be omega 1 upon omega 2 can be written as O2n upon O1n. Okay, now in this case let's derive it for term O2n and O1m. Now O2n is the distance which is sketched with red line, and over here it is O1m. Okay, now for this triangle let's consider for triangle P. For this triangle, okay, now for this triangle we have a basic idea that these common normals are parallel to each other. Okay, and this line is passing between them. So we can say that these two triangles are of equilateral form. So we can say O2n upon O1n, O2n upon O1m is equal to this intermediate line. We can derive this equation in such a way that O2n upon O1m is equal to, we can say O2p, because P is their common contact point. So is equal to O2p upon O1p, and this is the basic concept can be derived with geometrical equations. Okay, so now in overall term we can say omega 1 upon omega 2 is equal to O2n upon O1m, or is equal to O2p upon O1p. So now with respect to these O1 and O2 centers, this P point must remain at certain position, that the ratio must be same, and this ratio is defining our omega 1 upon omega 2 ratio. Okay, so in this way we can say that for law of gearing, the equation that is very essential, omega 1 upon omega 2, can be achieved and can be satisfied if the distance O2p upon O1p remains constant. And for that position, the P point is defined in such a way that common normal and common tangent must pass from this point P, and this is the basic condition of law of gearing. Okay, so this condition is very useful for designing a gear. How it works? So over here in this diagram you can refer that while meshing of two gear, that is gear 1 and gear 2, the common tangent point, this pitch point, is always passing from its common tangent and common normal. If you sketch common normal over here and common tangent over here, then you will always refer that it is always passing from this point. Clear? Okay, so this is the basic condition. So if you want to design profile of gear, then in that case you have to first, if you are choosing arbitrarily any shape of gear 1, then the shape of gear 2 must be designed in such a way that its contact point Q will be transferring your point P in such a manner that this P point remains constant for, and it is and its common normal and common tangent must pass from this pitch point. Okay, and if you are designing any gear with respect to its arbitrarily first gear, then that second gear is known as a conjugate gear. Okay, so you in this way you can design the profile of gear tooth in any shape, but conjugate gear, the design of this conjugate gear is very difficult. So in identical condition, mainly two types of threads are used mainly two types of threads or thread forms are used to achieve proper law of gearing. Okay, and these two type of gear form we will study in our next session. Okay, so in this session let's wind up that law of gearing statement, which is very essential for designing a gear, and it says that the common normal at the point of contact between a pair of teeth must pass from the pitch point. Okay, thank you.